Okay, hello everybody. Welcome to the Intro to Technical Interviews workshop. This workshop will be introducing you to all those technical interview questions that you might have. So let's get started. Okay, so we'll start off with introductions. So I'm Lucy. I'm a marketing coordinator at nwPlus, and I'm in my third year of computer science at UBC. We also have our lovely TAs with us. We have Jackie, who is the co-president of nwPlus, also in third year computer science, and Michelle, who is nwHacks director, also at third year computer science. So if you ever have any questions, make sure you head over to the Discord and pop them into the appropriate channel to ask your question. Yeah. Okay, so this will be our agenda today. So we've already been through introductions. Next, we'll go through what is a technical interview and the types, how to prepare and expect from each type. Then we'll look at all the steps to tackling each interview type. And then halfway through the workshop, we'll do an interactive portion where you're going to try and apply the steps you've learned to solve a interview problem. Finally, we'll end with do's and don'ts and also some resources. Okay, so if you're in first year or new to tech, you hear about technical interviews all the time, but maybe you're like, what the heck are they actually comprised of, and why do we do them? So most simply, it's you writing code or looking at code, and an interviewer discussing with you what you're doing and understanding how and why you're doing something. So the reason why we have technical interviews is to show your ability to solve problems, also to demonstrate your communication skills. Additionally, when you're doing technical interviews, you might have to dig yourself out of a hole and then break down a problem. And these are all really important skills that you will apply if you were working as a software engineer or just in a technical company. Okay, so there are three broad categories that you can break a technical interview into. So the first one is algorithm, the next one is a design question, and lastly is debugging. There's probably interview questions that can fit into both categories, but these are the most seen categories. So the first one we'll go over is the algorithm type of technical interview question. So this one is the most commonly seen one. You're basically given a vague problem statement, an input and an output, and you have to design an algorithm that can correctly take those inputs and turn into those outputs. In this type of question, you have the freedom to choose whatever programming language that you want to work with. And like I said before, this is usually the most common type you'll see. Next are design questions. So these questions are a little bit different. You're also given a vague use case, and you sometimes have to design a class or a set of functions to model that use case. Again, you can usually choose whatever programming language that you want to work with. And then there's a larger focus on data structures here. Obviously, this might not always be the case, but in the design questions I've been given, there's a larger focus on data structures. And there are also wide spectrum. So you can be designing a class like in Java, or you could just be talking about higher level concepts like technical architecture. And if you don't know what servers and databases mean, no worries. Usually you don't see this type of question as common unless you're doing like a specialized role. And lastly is debugging. So debugging is basically given a piece of code, you just find what's causing that bug. Sometimes you also need to provide the fix. And unfortunately, for this type of problem, you're going to be constrained to whatever programming language the interviewer gives you, since the interviewer probably doesn't have 50 copies of the same bug in every different programming language. So here you would have to, if you've never seen the programming language before, you have to kind of, I think, extrapolate based on what you've seen or know from other programming languages you usually work with. And this type of problem is probably the type that's most applicable to a day in the life as like a software engineer versus the other interview question types. So now that you've seen all the different interview types, you have to go about preparing, but that can be hard sometimes. So let's go over the things you should prepare for and resources you can use. So I'm pretty lazy and I don't like doing leak code. I think everyone doesn't like leak code that much, but if you do, that's awesome. And obviously more leak code is always better sometimes. And personally, I've only done 37 questions this year. So that's probably 0.2 questions a day. So what I want to just stress here is that I want to stress that learning concepts over time is a lot better than spamming problems, because each problem you see in an interview is going to be different. And if you just memorize a set of questions, it won't extrapolate well to like all these different questions you'll get in an interview. Obviously, that means if you want to learn concepts well and then build a strong foundation, you need to create a schedule to learn. And I think the schedule from Cracking the Coding Interview, the book, is really good. So I'm not suggesting that you take the copy off of the internet, but do know there are PDF versions of it floating around. Okay, so here are some courses at UBC and self-prep that I think are useful for algorithms. So here are some courses at UBC that will help you build the foundation for solving algorithm type of problems. 110 is a great foundation, as well as these other courses. I think 420 is not necessary, but I've included it here because it's like the advanced version of algorithms, the algorithm course. And then self-prep. So again, Cracking the Coding Interview has a lot of great questions, and they also have chapters based on concepts. So if you're not too strong with like graphs, you can just practice those questions. And I've also listed practicing live coding with a friend. So I think this is the most helpful type of question. Most helpful type of self-prep, because when you're practicing alone or even doing a course assignment, you usually don't have to explain your thought process to anybody. But in an interview, you will be expected to explain your thought process while you're coding. So practicing with a friend will show you which areas that you struggle with. Maybe when you are finding a bug, you realize that you're not really communicating that well. So then those are areas where you want to practice. And lastly, LeetCode, I have a star because while it's a great resource, I think other resources should be used in addition to LeetCode to prepare yourself for the algorithm type of interview question. And here are just a list of things to know. It's a lot of stuff to someone who might be in first year. I know if I saw this, I would be freaking out. But at UBC, CPSC 110 and 221, these courses will prepare you for all the concepts on this slide. So if you are planning to take those courses, or you are taking those courses, you don't need to worry, because you'll be sure to go through all these concepts. And also, if you're a beginner in tech versus someone applying to more senior roles, you'll be expected to know different levels of knowledge. For instance, I would say for most technical interviews, you should at least know how strings and arrays work. And then as you interview for other companies in like your later years of school, you'll then be expected to know how linked lists, graphs, and heaps work. Next are design questions. So on the left again are some courses I would suggest that help you with design questions. And there's a lot more that I haven't taken because I'm only in my third year, so I'm still taking CS courses. And again, self-prep. So Cracking the Coding Interview has, again, a lot of design questions. And then another thing I want to emphasize here are personal projects. So when you're working on a personal project or a course project, a lot of the time you have to be designing how the project looks. You obviously don't want your entire project to be one file or like one blob of code. So you want to kind of structure that code in a way so that it's readable and easy to maintain. So that's why I think personal projects are a great way to get better with learning how to work with designing your code, and also reading technical blogs. So some companies will have technical blogs that talk about their design choices. And if this is also great if you are interviewing for a company and you find out they have a technical blog, if you read about it and then ask them questions about it, it'll show that you're really excited about the role and also that you're serious about the role. And again, what you should know or what you should plan to know, I think design questions have a greater emphasis on data structures. So you want to be familiar with the runtimes on operations on data structures, like accessing an element in an array versus a linked list, as well as their memory use. And again, if you're in first year, you won't be expected to know things like graphs in depth, so you should be familiar with like strings and arrays. And additionally, I've listed here OOP, so that's object-oriented programming, which you'll learn in CPCS 210. And here are just a few concepts you should know, such as classes, inheritance, abstraction, and polymorphism. If you're asked to design something and your interviewer kind of wants you to design it in an object-oriented programming fashion. And lastly is debugging. So debugging is probably the hardest type of question to practice for, because unlike like the algorithms and design questions, there's no like checklist of what you should learn to debug, like checklist to learn about how to debug. So I would say any course that has a coding portion will help you to debug, because you will never write perfect code. So every time you make a bug, that's basically, and then also solving that bug is like practicing for debugging questions. So how would you prepare? So when you find a bug, you should not always go to the internet and look for the reason why. I know that's something we all like to do. I do it too, just search in Google what the bug might be. But if you find the root of the bug and then slowly solve it yourself, you'll then learn how to kind of go about finding the root, and also you'll learn something new. Additionally, personal projects, again, are a great way to learn how to debug, because again, you're making a personal project, you're probably learning a lot of new concepts, and when you're learning new things, you might make like a mistake. So when you are like learning something and applying it, and then working with learning how to use it properly, it's another way you can kind of learn how to problem solve. And lastly, you can also debug others' code. So if you are interested, you should also like apply to TA a computer science course at UBC, because you'll just be looking at students' code all day and just like trying to find out what's wrong with their code. But again, you can also, like when you and your friend can be working on a personal project, and you can help each other debug each other's code. Okay, so now we've kind of went over what these interviews are and what you should know for each. Now we'll go over the steps on to tackle each interview type. So these interviews might seem intimidating, but when you have these steps at the back of your mind, it makes it a lot easier. It's kind of like behavioral questions where you have the STAR method, situation, task, action, and result. Even if you're nervous, as long as you like go through those parts, then you'll be able to, the interviewer will at least see that you're trying to formulate an answer. So we'll first go over algorithm and design, and then we'll go over debugging after. So the first thing you always want to do is understand the problem. If you try to solve a problem without understanding it, I would say 99% of the time you will not be able to find the correct solution. So firstly, you always want to understand, what does the input data look like? Is it, for instance, for a string, is the input literally a string, or is it a list of characters? That can kind of determine how your algorithm or design will be shaped. And then next, you want to actually know what you're doing. So if you don't know what you're doing, then it's going to be very hard to create an algorithm for it. And then next, you want to actually return the proper thing. So if you return the wrong thing, obviously that will not be solving the problem. So you should always establish these three things as soon as possible in the interview. And the way to do that is just to ask questions, because your interviewer is there for answering your questions, and they gave you the problem. So you should ask them to clarify as much as you need. Lastly, you also want to ask about what is a good solution. So sometimes this might just mean returning it, like they don't care, and this might just mean like returning the solution, but the interviewer might also put memory constraints or runtime constraints. For instance, if your algorithm takes too long to return a solution, that might be a bad solution even though it returns the right thing. And lastly, for design question, you always want to ask about use case, because the use case can also help you formulate a solution, because those details will be important. And next, what you want to do is just provide a brute force solution. So what this means is that you want to find the most intuitive or easy solution. So don't try to pre-optimize or think like a computer at this step, because you'll get, like in an interview, you're nervous. So if you start thinking about the small details, you might get confused yourself, and the interviewer won't know what you're trying to do either. So what you want to do is just say a solution that's intuitive. It's probably not a good solution, but the interviewer might help you out and say, yeah, that's a good starting point. So how can we make it better? Or the interviewer might say, I was thinking of another way you could do this. So once you've figured out the solution, then you can try to make it more technical. And while in this stage, you should be thinking about edge cases, but don't focus too much on them. Just make sure you have edge cases in mind. The next is improve. So the first solution you come up with, unless you're really, really lucky, is usually not the best. So here are some points that you can think about when improving your solution. So if you're calling the same thing more than once, and then that means that you could probably improve your runtime. So what that means is, for instance, if you're calling something recursively multiple times, if you could save the result of the recursion somewhere, that could improve the runtime. And next is there's something that could be done in place. So if you're doing something let's say you have two lists and you're copying elements from one list into another, is there a way that you don't need to copy those elements? You can just switch them or swap them. If you could, that could improve the memory time. And next is about the input. So do you need to check the entire input? So sometimes parts of the input are irrelevant. So if you're able to establish that you can still find the correct solution without checking the entire input, this could also improve runtime. And while you're improving your algorithm, make sure that you're still covering all edge cases and producing the correct thing, because sometimes you can accidentally do something that makes your algorithm incorrect or your design incorrect. Next, once you've talked with your interviewer about what you could improve, you want to actually state this solution that's better. So here you just want to tell the interviewer what could be improved, what can't be improved, and make sure to start mentioning technical details here. So at this stage, you should be mentioning like data structures you would use, estimates of runtimes. So then it will also help you start thinking about how to code your solution. Okay, next, before you start, 110 has pounded this into your mind, but you should template or at least have a general idea of what you're doing. So before you start, and this is what I like to do, I just fill in everything I know. So if I know what a for loop looks like, I'll fill in the for loop. If I have constants I need to save, I'll put it somewhere. So then you just develop this kind of structure for your algorithm, so you're not just typing into a blank file. And also, so like that means your algorithm starts coming alive, and then you can point at parts of your algorithm to your interviewer, which will also help them understand what you're doing. And also, if you need to code a complicated step in your algorithm, but you don't want to do it now, you can add wish list entries, which are what they are called in 110, or just comments to remind yourself. For instance, like, so I would imagine that I would have a helper function that does this, but I don't want to code it right now. Then your interviewer will say, okay, I understand. So that way, your interviewer can stay on the same page as you. And this also helps you start templating and thinking about the actual implementation. And next, you can actually implement it. So if you have a template, try to follow it, because if you start to code without following it, your interviewer might be confused. And they'll be like, so you had a for loop here, why aren't you using it now? So make sure you follow the template as best you can. And also, I would say to not try to attack the problem by coding it line by line. So you want to like fill in the parts you know, instead of going through it line by line. It might happen such that you do go line by line, but you kind of want to go in a way that makes sense to your interviewer and yourself. And I just want to emphasize that you should be talking throughout your implementation. So the interview should never have no one talking. There can be pauses, but there should be at least one person talking throughout the entire interview, and there also should be like a conversation. So shouldn't be like you talking straight and then your interviewer talking straight. It should be like you asking questions, you making statements, and your interviewer answering those questions and also confirming or objecting to the statements you make, because they're here to help you and they want you to succeed, and they're also trying to see if you are able to communicate well. Next, once you're done your algorithm or design, you want to test and validate. So at this step, you want to mention your runtime and memory use, because those are important parts of the algorithm. You always want to be trying to improve runtime and memory. So this will also indicate to your interviewer whether or not you found the best solution. Additionally, if you have time to talk about, you can also mention some test cases you would use. Personally, I've never had enough time to like design an entire test suite, so I would just talk about tests that I would like to use on my algorithm. And this also shows your interviewer that you know how to correctly validate a piece of code. And next is fix bugs. So this doesn't always happen, but you're going to encounter at least one interview where you think you're done, and then your interviewer says, hey, this is actually not the right solution. So first off, understand why this bug occurs. I think interviewers are usually pretty helpful and they'll point you in the right direction to the bug. So just ask your interviewer for help and say, so I have an idea where the bug is, but I'm not sure. So just ask your interviewer and they'll point you in the right direction. And once you've figured out what is wrong, go and implement the fix. So obviously this is easier said than done, but using the same steps as before, you can try to fix your algorithm. And lastly, make sure to check if runtime or memory use has changed, because if you've changed the algorithm, maybe something's changed. So just make sure all of those parts are still the same, and always make sure your algorithm is correct to the best of your abilities. And lastly, discussion. So you've obviously made some choices in designing your algorithm, so you want to tell your interviewer why. So why are you using this data structure? What is the advantage to using A over B? What are trade-offs between using A and B? And also, sometimes your interviewer will also ask you about a different solution, and then you might want to talk about like, my solution is better because, or that solution is always also equally good because. And then last step is extending. So in design questions that I've been asked, the interviewer has always asked me like, so if I wanted your class to do this, how would you implement that? So you want to kind of talk about that as well. So also be open to it. When an interviewer asks you this, it doesn't mean you did something wrong. They just want to see if you understood what you did, and also see if you understand how you can extend your code, because that's an important part of working. Like as a software engineer, you're going to always be working off of code and not just starting from scratch. And yeah, so extend here is pretty open. So they might also ask you about alternate solutions that you didn't consider. Like, I saw your algorithm did it this way. What if we did it that way? Would it still be the same? A common example of this is, I've seen you use recursion. What happened if you did it iteratively? Can you explain what the differences are and why you chose recursion? Something like that. And next we'll go over debugging. So debugging is a little different. So here you want to take a high-level look at the code. Do not get too into the details, because you're going to spend too long looking at each line, then you won't actually find the bug. So you want to ask as many questions as possible. Your interviewer might not be able to give you all the answers, but if you can determine, for instance, what inputs this bug occurs on, is the bug systematic or random, and which class the bug affects, it can really help you in finding the bug. So just ask as many questions as you can. Next is that you have to find the bug. So if they give you buggy output, find which methods are producing that output. So basically this means you have to trace the method calls. So if the bug happens in method A, and method A calls method B, then you will have to go look at method B and see what's happening. So if you're also given access to a stack trace or a back trace, I'm not sure what the correct name is, that's also very helpful, because it will show you all the methods that led up to the bug. And next, if you have a debugger, use it. So another thing you should learn is how to use a debugger. So in CPSC 210 is where you'll learn how to use a debugger, and debugger is extremely helpful. If you're unable to use a debugger, then you will want to keep like a piece of paper out to write down all the steps or details that you want to keep, because a debugger allows you to see the state of something. If you don't have access to it, you have to remember the state yourself. And next, something really helpful is to draw or write out what is happening. So in an online this is hard, but basically you want to be able to talk about your thought process. Sometimes in online interviews, I think they can give you like a board to draw on, and then that way it's easier for you to talk about what you're seeing. And then also I want to emphasize throughout this debugging interview, you always want to talk about. So for instance, you'll tell your interviewer, so the bug is happening in method A, and I see that method A calls method B. So I'm going to go check what method B does. So you should actually tell your interviewer you're doing that. You shouldn't just click on method B and then just look through it without telling your interviewer. So just talk throughout. And lastly, this is fix the bug. So like there's only 3 steps, because debugging is pretty, I think it's like different. It's not something you can always prepare for. So that's why there aren't as many steps. So if you're asked to provide a fix, you want to do that. So it's hard to kind of determine what the fix might be because bugs are so different. So first you want to just determine what is the correct output. And then based on that, you want to look at what's actually producing, which might give you insight. So let's say the correct output is 5, but it's returning -5. Then you might be thinking, so there's somewhere that it's multiplying the output by a negative number, or something that's just happening that's making it negative. And that can kind of help you find where the issue is. And then, yeah, so this is probably the hardest part. And again, always talk with your interviewer who will point you in the right direction. Okay, so now we've just been talking through the steps, and then, but what you always want to do is you want to apply these steps, and then once you've applied these steps, then you'll make sense to you why you should follow the steps. And also, it's always good to get in some practice. So a common thing with technical questions is that they will bombard you with words, and then you might be freaking out because you don't know what this word means, you know what that word means. So if you don't understand the concepts like terminology, don't worry, because it's not important in this problem. Okay, so protein and RNA. So basically, when a piece of RNA is being translated, and RNA is just a sequence of letters, there's something known as the open reading frame, and I'll abbreviate this as ORF. And ORF are the nucleotides that get translated. So an entire piece of RNA is not always translated into proteins, and then what tells the cell to start translating is known as the start codon, and the start codon is just 3 nucleotides. And then what tells the cell to stop translating is the stop codon. So nucleotides must be translated as groups of 3, and RNA can begin to be translated at any point. So reading all this information, if you're not familiar with biology concepts, you're probably thinking, oh God, what does this all mean? How's this a technical question? But we'll just break it down. So this is, for instance, the interviewer will give you kind of examples of what they want. So a start codon is AUG, just a string AUG. A stop codon are these 3 strings. So for example, if the RNA was this string, the open reading frame is everything in yellow. In example 2, this piece of RNA has 2 open reading frames, so everything in yellow. So while RNA is not always in multiple of 3, it will be for the purposes of this workshop so that you can just focus on the steps. And then what the interviewer would be asking for is to return the length of the longest open reading frame. So for example 1, that would be 9, so like 9 letters. And then for example 2, that would be 12 letters. So we ignore this second yellowed part because that's 3 letters, and 12 is more than 3. Okay, so the first step is to understand the problem. So what might be some questions you ask to better understand the problem? So I can just go back here, and then if anyone wants to, they can send questions to the chat. I'll give you a few, like a minute or so, and it's totally understandable if you don't know what questions to ask, because this can be a complicated problem if you get intimidated by the terminology. So just what I like to do, if the interviewer starts giving me questions with terminology that I don't understand, I just look at the examples and try my best to formulate questions based on the examples. So I'll just wait a minute or so. If not, I'll put up some questions that I would ask. Oops. Yeah, so one question is, so you can choose which stop codon to use. Yeah, you can choose any stop codon to use. So let's see the second part. So like if there's multiple stop codons, can you skip the first one? So that's a really good question. So let's say if there's two stop codons, you have to stop at the first one. So you would not be able to skip the first one because the first one tells you to stop. So then the cell would just stop translating, or in simpler terms, the open reading frame would just end. You're not allowed to have a stop codon in your open reading frame. So do we count the start codon and stop codon in length? So those are not counted in the length. So everything in between them is counted in the length. So here, in example 1, it would be 9. And then in example 2, it would be 12. So we don't include the start and stop. Okay, those are some really good questions. So I'll kind of list out some questions I might ask. So oops, this is what I would try to understand the problem as. You have a string, and you just want to return the length of the longest substring between two constant substrings. So that's basically, if this was not like a biology question, you just be returning the length of a string between two constant substrings. Next question is, I would ask, can there be more than one start codon? And the answer is yes. And then someone also touched on this question, if there can be more than one stop codon. The answer is also yes. And then the next one, which another person also asked, is if you can keep going past a stop codon. The answer would be no. And then I'll have an example that shows that. And the next question I might ask is the longest open reading frame always the first start codon? So if there's multiple start codons, is the longest open reading frame going to always occur at the first start codon? The answer is no. And another question might be, can you keep going past our start codon? And that is yes. So if you see start codon and you're already counting the number of letters and you see another start codon, you can keep going. So the only time where you can't keep going is if you see a stop codon. And before we get started, here are just some tips. You can do this problem in any programming language that you prefer. I will be doing it in Python. But if you're coming from Racket, this syntax is equivalent to the Python. So the substring, wait, I did this wrong. Okay, so yeah, I did this wrong. So that's not how you write a function in Racket. So yeah, you can ignore that, but the parentheses should be on the outside of substring, and that would be equivalent to the Python. So if you know, I think at this point, if you know Racket, you know how to do substring. This is what happens when I write the slides at 6 a.m. on the bus. But yeah, you can ignore the wrong syntax for Racket. I'll just type in the correct one. This is also embarrassing because I TA 110, but we can ignore that. So I just sent in the Discord, this is the correct way it should look. So yeah, if you're coming from Racket, that's the Python equivalent. And in Racket, you haven't learned about for loops yet, but I'll just be using a for loop in my solution. Okay, so this is a string. So if I were doing this question, I would first draw out a string with all the indices of it. And this would just help me in figuring out how my algorithm should look. So you can also refer to this slide yourself just as you're solving the problem. And you can obviously choose a shorter substring because this one's, or shorter string because this one's really long. Okay, so brute force. So the first thing you want to think about is what might be the easiest way to find the longest substring. Again, I'll give a few minutes for people to think about it. And at this step, just think about what you would do kind of yourself, or what's just the easiest thing to do. I see someone's typing, so I'll just wait for them, and then I'll talk about what I would think to do. Yeah, so one solution that a hacker mentioned is that just iterate through the string until I find the start codon, then continue iterating until I find a stop codon, keeping the bases I encounter as a list, then I'll return it as a string later. So that's a good way to start about it. And then just one thing, if I were the interviewer, I would say, so remember, we're just returning the length. So what you would do is also just turn it like back into a string, or you can just find the length of the list. So you would just return like the length of the list with length of string. But it's a definitely great start to the problem. So here's what I would do. So I would find, it's very similar. So I would find all lengths of open reading frames. So that's basically just brute force, just finding every single open reading frame, and then just keep track of the longest one and return the longest one. Yeah, so you would just have a count variable. So how this would go about is you just find a start codon, find the nearest stop codon, and then record the length as max if it's the longest so far, and then continue off from where you were and find the next start codon, repeat. So the highlighting is not very, I don't know if the highlight is like very strong, but here the AUG at 3 to 5 is a start, and the nearest stop is UGA. So the length would be 15 minus 6, which is 9. And then in the next step, where we would start iterating where we left off, where we would then go back to like 6 and then keep checking if there's another start codon, which is at 9 and 11, and it shares the same stop codon. So the length would be 15 minus 2, which is 3. And then after that, we would go back to like, I think somewhere here, and then keep checking there's a start codon. And we see there's one at 18, and then its stop codon is at 24, and that length is 3. So in this problem, we would return 9. Okay, so then this is just brute force, but in more technical terms, what you kind of say to the interviewer. So iterate through the string until you find a start codon. If we do enter another for loop, which iterates through the rest of the string, if a stop codon is found, record the length if it is the longest we've seen, So this is recording the length of the open reading frame, and repeat steps 1 to 3 until we have reached the end of the string. So the next step after this, after we explained the brute force solution, is that we would want to template it. So I have a Python file open. So this is how I would start to template it. So first you want to write out the function name. You can just call it longest ORF. And then also I'm going to use the types in Python. They're non-forced, but they're a good reminder. So the RNA is a string, and we're returning an int. So I'll give you, and then also put in the constants. So I like to store any constants I have in a list. There's other ways to store them, but I think list is the easiest. So this is me just setting up my constants. And then max length, I'm going to initialize it to 0. And then when you're initializing variables, you kind of want to explain why. So you could tell your interviewer, so if there was no open reading frame, then it would make sense to return 0. Sometimes you might initialize to -1, but that doesn't make sense because you can't have a negative length. So I'm just going to initialize to 0. And then you will want to start templating. So I'll give you a few minutes to think about it yourself, and then I will put the template that I will write out the template that I would have written out. And you don't need to share your template at all. You can just do it on your own computer. So if you don't have like Python running, you can just search up Python REPL, and then you can do the same thing, but in a REPL. If you do have Python on your computer, you can just do it there. And I also encourage you to do it in a programming language you're comfortable with. So you can do it in Java or Racket, whichever language is most familiar to you. Okay, so I'll wait 1 more minute. Okay, so basically I'm going to type out, so I'm going to talk through it like I was talking to an interviewer. Okay, so in my brute force solution, I mentioned that I would iterate through the string and then iterate and then find a start codon. And then after I find the start codon, I'll iterate through the string to find a stop codon. Then after that, I'll find the length of the open reading frame and then save it to max length if it's the longest. So that means I need a for loop. So I would say I'm making a for loop just to find the first start codon. So I'm going to be just creating my for loop, and then length RNA just finds the length of a string in Python. And then I'm going to subtract 2. And here I'm going to say, since a codon is 3 letters, if I need to check for a codon, I need to check for like the current letter and the next 2 letters. So in order not to iterate to the end of the string, then I need to stop iterating 2 letters before. That's why I'm putting -2. So then I would say I'm going to create a variable for a potential start, which will be RNA I plus 3. So I'm just going to say this will take the current letter and also the next 2 letters of the RNA. And then I'll say I'm not sure what to do next. And then I'll just put like ... to signify to my interviewer I'm not sure what to do next, but I know there needs to be more things to do. Then I'm going to have a for loop again. So I'm going to say I'm going to have another for loop that if I do find a start codon, then I need to start looking for a stop codon. So for j, this also has to have in. So for j in range I plus 3 to length RNA minus 2. So I'm going to tell my interviewer, I need to look for a stop codon that is after my start codon. So I'm going to do I plus 3 because I don't want a stop codon in the past. So I'm just going to check the string after the start codon. And again, I'm going to subtract 2 to make sure I don't iterate out of the list or the string. And then I will create another variable, potential stop, which will be RNA. And then I'll make sure that I'm using J and not I. And then again, I'll say I'm not sure what to do after this step, but I know I need to do something. And then lastly, I will just return max length. So then this will be your template for this question. So from here, you can see you have a lot of the structure in. There's a lot of the structure down, and there's not much logic yet, but this is important because your interviewer is like, okay, so they're going to be using 2 for loops, and they're going to just be checking if this is start and stop codon. So if we go look, this is the exact same template. So basically, you initialize all your constants and set up your for loops. So now you need to actually implement the logic of, for instance, find the length of the open reading frame. So in this picture, I've decided that this AUG and this UGA will be the start and stop codons I find. So when the first AUG is found, I will be equal to 3, and potential start will be RNA 3 plus 3, which is AUG. So yeah, and then when I look for the stop codon, J will be equal to 15. So then the potential stop will be RNA 15 plus 3, which is UGA. And we see that we find the length by subtracting 15 from 6. So then if you put the variables back in, it'll be equal to J minus I plus 3. So then this is basically the logic, and you figured out how to find the length. So then you can fill it in. So to fill it in, I would just go here. So fill it in, I would say, first you have to check if this codon is a start. So you can do if potential start is in start codons. And this syntax is very Pythonic. So in Java, you'd have to do a different mechanism of checking if an element is in a list. When Python, this is okay. So then if the potential start is in start codons, this is when you would want to start iterating and checking there's a stop codon. So you just put your for loop in here. And then, again, you do the same logic. So if the potential stop is in stop codons, then you would stop and find the length of the string. So then you would do length of the open reading frame is J minus I plus 3. And how I'm explaining it now is how I would talk in an interview. And then I would check if this is longer than the current max length. So you do max length, and then in Python, you can just do max, and then you put 2 numbers in there, and it will return the larger of the 2 numbers. So you can do max length, and then the length or f, and it will just return whatever is longest. And then when you found the stop codon, since we do not keep going, once you found a stop, we stop, you would break. And this means break out of this for loop, and then it will go back to continue looking for a new start codon. So then this would be the solution that I would come up with. And this is the brute force. So there's a much better solution that we're going to find later. So now that we have this brute force solution, what we want to do is see if there's anything we can improve on. So does anyone see anything that we can improve on, or anything that just looks bad? So basically, what I mean by that is there anything that is taking a long time to do, or is anything that just using a lot of memory? So I can just say that this solution doesn't use that much memory, because all we're doing is saving the max length in a variable, and we're saving the start and stop codons. And then I'll give you a moment to think, because my laptop will die. Okay, I've plugged my laptop in, so my laptop will not die. Okay, so here we can see that the memory there's not that much memory being used. However, there are 2 for loops, and then our 2 for loops can take a long time because we'll talk about this later, but iterating through for loop will take as long as the input is. So we can call the length of the input n, and then the for loop will take n time to iterate through. If we have 2 for loops, so we have 2 for loops, it's going to take n times n. It'll take n times n. So our second for loop doesn't always look through the entire string, but we can just say it's close enough to n that it will be n times n. So basically our solution has a nested for loop. And then if we look at this picture here, the light green AUG to the UGA, the length will be 9. If there's a start codon inside of the open reading frame, so this start codon, the 9 to 11, is inside of this open reading frame. If it's inside of it, then it's always going to be shorter because it's going to stop at the same stop codon, so it's always going to be shorter. So that means that we're going over the string multiple times in the same place, and they're often redundant checks because we can confirm that this will always be shorter, which means we possibly might not need the second for loop. And then this is just another picture making it more clear. So the orange is like the first for loop, and the blue is the second for loop. And we see here the blue and the orange are checking over the string in places that we don't care about because we already know this one will be the longest. So that means we can probably eliminate the second for loop. So can anyone think of a better solution? And I can give you a few minutes to think about it, but you might have already found a better solution, but that's totally okay. I'll wait until 1:58. Okay, so since we've decided that we might not need the second for loop, we're just going to try and iterate through the list once. So then basically we tell the interviewer we can do this because we can ignore any start codons in the open reading frame because they will always produce shorter open reading frames. And this picture just emphasizes that again. So then I'll talk to my interviewer about what I think the better solution could be. So we can iterate through the string groups of 3, or you don't have to. So basically, I decided not to include this in the solution, but you can. So we just iterate through the string one by one. You can ignore the groups of 3. So then there's 2 conditions we have. We either have the the start of an open reading frame or we don't have the start of an open reading frame. So the easier case to look at is if we don't have the start of an open reading frame, we will just search for start codon. And then once we do find a start codon, then we have an open reading frame. So then after we have the open reading frame, we search for a stop codon. And when we find a stop codon, record the length if it is the longest we've seen, and set that. And then after we found the stop codon, we set it back such that we no longer have the start of an open reading frame. So then the way I would improve my current solution here, so we've decided that that we're going to have another variable here. So in addition to max length, we're going to have a start open reading frame, and basically this will just tell us if we do have a start codon right now. So I'm just going to set it to none. None means we don't have one, and then you're going to start kind of deleting parts of your code. So, but don't do it too hastily because you still might need it. So basically, we still need this for loop. We need at least one, so we can keep this one. But now we don't know if a codon is stop or start. So I would change this just to be called codon. And then we will just make two if statements or an if and an else for our two cases. So then what I would do is, so if the codon, so we decided that if we have the start of an open reading frame, then we can just do if start or f. Basically what this means in Python is if start or f has something in it that's not none, then it's true. So then if we have a start of an open reading frame, we will do something. Again, this is like the templating step. So you just put in ... so your interviewer knows you're going to come back to it. If we don't have the start of an open reading frame, then we have to check if the current codon is the start of an open reading frame. And this logic's easier, so we can just do it now. We can just say if the codon is in, if codon in start codons, then we can assign it the open reading. We can assign start or f to something. So you can assign it to a start, or f will be equal to I+3. And then in a picture, I'll show you why we're just setting it to I+3. And then we go back here. So if we do have the start of an open reading frame, then we want to check if we have a stop codon. So we just do if codon in stop codons. If it is in the stop codon, then we need to stop and then calculate the length. So then we can just say a length of the ORF is equal to I minus start ORF, and this is exactly the same as this one. So j minus I+3. So we saw that we made the start ORF I+3 just to make it easier, and now j is instead just I because we only have one for loop, and we do the same assignment to max length. So if it's max, then we just do len or f max len. It would choose whichever one's longer and then return it. And then we don't even need this anymore. So we just delete that, and then we're basically, and one last step. So if we've found a stop codon, we record the length, then we set the start or f to none again, just to make sure our algorithm will then search for a new start codon. So make sure you include this step. And then this will be our new algorithm. And then we can click here, and this should be pretty similar if I didn't make mistakes. So I = 0, you don't need that. I was probably just added it randomly because I was too tired to notice. But this would be our new solution where we just iterate through the list, the RNA once. And then we have two cases. If it's a start, if we do have a start codon, then we search for a stop. If we don't have a start codon, we search for the start. Okay, so then this picture kind of explains the logic again. So the start, so just codon is just the RNA 36, and then since it's a start, we will assign start ref to 6, then I is 15, and if the codon is stop, we'll find the length. Okay, so now we have to test and validate our solution. So fortunately today our solution has no bugs, but that's because it was in a workshop. But what you want to do is now look for the runtime. So you look for lines of code that are not constant and think about how they would grow in relation to the input size. So if we look at this code, what is the worst case? So since we're running kind of short on time, I'll just say that the worst case is that there is no start codon. So you just keep checking the string for a start codon, and then you never find one. So that means we still have to check the whole string. And then the best case would be, so the best case is if you have a start codon and then you kind of realized your length is already more than half of the string, then there possibly can't be a longer open reading frame because the current one you have is already longer than half of the string. So you could prematurely end, but that's basically n over 2. But when we're analyzing runtimes, we always think about, we want to kind of think about it as it grows on large inputs. And then n over 2, we can just say it's similar enough to n, in which that the best case is also n. So that means our runtime would be a big O of n. And what that means is it grows based on how long the input size is linearly. So it grows linearly. If the string is 10 letters, it will be like, let's say 10 seconds. It takes 10 seconds to run. If our string is 5 million letters, it'll take 5 million seconds to run. So it just grows linearly. And then the runtime of our old solution was n squared. So that would grow quadratically. So that means if our string was 10 letters, it would run for 100 seconds. If it was 500 letters, it would run for a very long time. So 500 squared. Okay, yeah, so we don't have any bugs in our solution, but sometimes you do accidentally have a bug. So would anyone be able to notice what the bug is here? And then I'll just give like 2 minutes to think about the bug here. And then also what kind of test you would use to catch this bug. Okay, so this was a bug that while I was writing like the code for it before, this was a bug I did. So if you see here, I subtracted length -3 instead of 2. And the reason I was thinking that way is because I was kind of thinking like, oh, if the list is 9 long, then I want to stop like the last 3. So I just do -3, which is 6. But then you need to remember that lists have 0-based indexing. So if you subtract 3, it's not going to check the entire string. It's a one-off error. So you actually need to subtract 2 because lists are a 0-based indexing. And a test that could catch this bug is if you had a stop codon as the last 3 letters. If you had the stop codon as the last 3 letters, this code will not be able to detect that there's a stop in the last 3 letters. Okay, here's a challenge. If you're in 110, you can try it in Racket. I did this really quickly. I think it's almost right. But if you don't know what this means, okay. I just want to show that it also works in different languages, and this solution is also recursive. So yeah, if you want to, you can try it in Racket and then compare with mine. And if you find any bugs in it, in my solution, you can just let me know on LinkedIn or Discord. But yeah, you can try it in Racket, try it with recursion instead of for loops. So yeah, if you got here, if you're just following along and you're able to answer some of the questions I asked, then you're doing pretty well. So basically, you were able to solve it. And then lastly, before I let you go to your next workshops or whatever else you have to do, so here's some do's. So you want to always talk throughout your interview, especially if you're lost. So it's easy to talk when you know what you're doing, because you can just talk about what you're doing. But if you're lost, it can be very hard because you might be feeling nervous, you might be feeling stressed. So then you might want to climb into like a corner and not talk to your interviewer. But please try to talk to your interviewer. They want to help you, and if if you tell them why you're lost, they can be like, okay, so have you thought of it this way? And they will try and help you. And next one is to start early. So build a strong foundation versus memorizing solutions. This one is hard, especially if you're a student, you're busy, you're taking other courses. But I would say just try your best. Do like an hour a day. That's what I would try to do. But also, if you're a student, try to work hard on your courses. For instance, in 221, really try to understand the concepts being taught to you. I know it's like, for instance, for me, the concepts in CBCS 221, they went by really quickly. And then I didn't feel like I could absorb them that well in the 1 week they gave us before they tested us on a quiz. So then after the quiz was done, I would go and look at those concepts. Even though we're not going to be evaluated for them anymore, I just looked back at it for my own like personally, because I wanted to understand it, and also so it would help me be better at technical interviews. Third is to practice with somebody. This is especially important. When you're practicing alone, you could talk out loud, but there's no one to just be like, Lucy, I don't know what you just told me. Definitely many times through practice, my practice interview would be like, I have no idea what you just told me. And then if you catch those like miscommunications, if you can catch yourself and fix like those times where you can't explain well, then you'll be better at the actual interview. And also, talking is nervous. Like if you don't like to talk and then suddenly you need to talk while coding, it's really easy to get lost. And then talking is not easy. I just want to emphasize that. A lot of resources, or like it might look like it's easy to talk, even though I'm doing this presentation, but it's hard to talk and it's hard to articulate your thought. So practice always is better, especially for like talking. And then if you do know which company you're interviewing with, I would highly suggest to read their blogs, search on Reddit, career sites, to learn about the types of questions they ask. So I think for like Google, they really like to ask questions that focus on dynamic programming, I've heard. So if you don't know what that means, you can just ignore me. But if you kind of know that, and then maybe you've had friends who've told you that, or like friends who've interned at Google and just were like, hey, you should kind of focus on these areas, then definitely put a stronger emphasis on those areas. And then don'ts. So do not only work on the inputs the interviewer gives you. Interviewer just gives you nice inputs. They're not going to give you an edge case because they want you to find that. And then next one is don't start coding without understanding the input or the output of the algorithm. So for instance, in your brute force solution, you might be like, I'm going to return the longest open reading frame. But then your interviewer might say, oh, we don't need that. We just need the length. So that means by just talking about your brute force solution out loud, your interviewer can just correct you before you start thinking about that. And then you make an optimized solution, but then you're returning the wrong thing. So just always talk. And then basically make sure you can just ask the interviewer explicitly, like, am I understanding this correctly? Like, just be explicit with it. That's what I like to do. And then next is the similar idea. Just start coding without knowing an idea of your solution. And then lastly, only memorize solutions and understand how they work. So something that I'm guilty of on LeetCode is if I spend like 2 hours on a problem and I can't get it, I might look at the solution and then I'll be like, oh, I get it. And then I forget about it the next day. So you really want to understand why the solution works. So a good way to do that is like you look at the solution and you come back to it like a few months later and try it again. But that's not always the best way because maybe you've just memorized it since then. And lastly, here are a few resources. So I think Cracking the Coding Interview is a really good resource. You can find it online just by searching it. Also, this tech interview handbook is also good. And on LeetCode, I saw that I think recently they just curated a bunch of questions, like top interview questions. And I just went through those, and they basically test for concepts like linked list, graph array, which is good for you to identify where you're having trouble with. Like if you're having trouble with arrays, you want to practice more of those. And then, yeah, so you're done. You've made it to the end of this Intro to Technical Interview workshop. And hopefully you've walked away with some more knowledge on how a technical interview would look like, how you would prepare for one, and how you would tackle one. And then lastly, don't forget to collect your stamp. I'm pretty sure that's happening somewhere in the HackCamp Discord. So yeah, just make sure to collect your stamp before you go about the rest of your day. So yeah, thank you for coming to my workshop, and have a good rest of your day.